Welcome to the first video of the Alarms series. Today you will learn about the basic concepts of alarming, as well as understand different alarm types supported by EcoStruxure Power Monitoring Expert System. Let's get started. We will start by explaining some basic terminology and definitions. First, let's clearly define what we understand by the term alarm. According to the industry standards, an alarm is a mean of indicating the presence of an abnormal condition that requires operators' response. That means the alarming should only be linked to problem happening in the system, and alarms should not be associated with informing about normal, expected process conditions. It is important to distinguish an alarm definition from its occurrence. Alarm definition is part of the configuration phase of the system deployment, and it includes the conditions that need to be met in order to trigger the alarm. An occurrence, on the other hand, is each instance of these conditions appearing. It is directly linked to the operation phase. Note that one alarm definition can have many occurrences over time. So, how are the conditions to trigger an alarm defined? In fact, there are several parameters that can be used. The first and most obvious is the pickup threshold. It defines the value of the measurement which is used to evaluate the alarm condition. Similarly, one needs to define the dropout threshold which will be used to make the alarm go inactive. The pickup and dropout thresholds could be equal. However, for analog, non-binary measurements, they are often slightly different to provide the alarm deadband, sometimes referred to as alarm hysteresis. Alarm deadband is a range around the alarm set point, created to avoid alarm triggering by small fluctuations in the measured value. Another parameter allowing to fine-tune the alarm definition is the pickup and dropout delay. It allows to make sure that the alarm will go active or inactive only when given conditions are stable enough. This is yet another way to avoid unnecessary multiplication of alarm occurrences or false alarms. To sum up, an alarm will go active only when the pickup threshold is exceeded for a time longer than the pickup delay, and analogically it will go inactive only when the dropout threshold is exceeded at least for the time defined as dropout delay. The parameters described so far will decide whether the alarm will be active or inactive in a given moment. In other words, they decide when an alarm occurrence happens. These two states provide information about the condition of the alarm. However, there is another equally important aspect to alarming, which is the operator's awareness. To track this, acknowledged and unacknowledged states are introduced. Marking an alarm occurrence as acknowledged means that the system operator noticed its appearance and is aware of the abnormal situation. In EcoStruxure Power Monitoring Expert System, there are many different types of alarms supported. The first classification is based on where the alarms are coming from, and there are two categories. The first one is onboard device alarms. We talk about onboard device alarms every time when the alarm definition is located on the connected device, such as power meter, and it is that device which is evaluating whether alarm condition is true. The device will not only make the alarm state go active, but it will also record a timestamp of that event according to the device's internal clock. For that kind of alarms, PME system acts as an aggregator and notification engine. On the other hand, there are software alarms, which are alarm rules defined directly on the system's server. It is the PME software which is monitoring parameters and evaluating alarm conditions. For software alarms, the alarm timestamp is recorded by the PME software according to the system server's clock. The scope of onboard device alarms depends on specific device type, its alarming capabilities, and support in Power Monitoring Expert. For example, a very popular series of power meters, PM5100, offers 29 predefined alarm definitions. The device driver includes Modbus registers which contain information about the current alarm state. The PME server will check these registers every 30 seconds by default to see if there are any new entries. In case a new alarm is discovered, it will appear in the system's alarm application. For the software alarming, EcoStruxure Power Monitoring Expert offers 25 different alarm templates, which allow to easily define alarm definitions. They can be used to monitor real-time parameters as well as logged data for a wide range of applications. Please refer to the alarm's configuration video for more details about PME's software alarms. Another classification is based on what is evaluated by the alarm rule. The first option is real-time alarms, which are based directly on the live data coming from monitoring devices. These are very useful for applications related to power management or status monitoring. They are also used to monitor the communication with connected devices or critical parameters that require immediate notification in case of abnormal value, such as temperature. Real-time alarms are available as both on-board device alarms and software alarms. The other type is logged data alarms, which are primarily used for alarming related to consumption monitoring. Such measurements typically cannot be evaluated based on real-time instantaneous readings. They require aggregation over time. Note that logged data alarms are only available as software alarms, and they need to be configured inside PME system. The last classification type is based on how the alarm definition evaluates the measurements. Most common alarms are based on a fixed set point. They use predefined fixed value of the threshold to trigger active or inactive condition. Such alarm definitions are very useful to monitor whether a measurement does not exceed a well-known expected value, for example, the subscribed power for demand monitoring or nominal power for transformer load monitoring. EcoStruxure Power Monitoring Expert offers also another way to define the set point. Smart set point alarms allow to use a statistical approach to continuously calculate the threshold values. This is a very useful way of capturing abnormal energy consumptions, which do not follow a general pattern. For example, an alarm can be triggered every time when aggregated daily energy consumption exceeds the average value for a given day of week by a defined range. Please note that Smart Set Point Alarms feature is exclusively available for software alarms based on logged data. I hope you found this video helpful. Please refer to the Overview of PME Alarming Applications video to learn more about advanced features around alarming offered by EcoStruxure Power Monitoring Expert. Thank you for watching.